Hey there, we're getting into division again today. So dividing a decimal number by a whole number is the learning task. And right now, hopefully you have a spiral notebook or some paper to work along with me. Some paper and a pencil would be good. It's always good to take notes during these videos. You learn more by doing with me, not just watching. All right, so here is the first problem. We're going to go ahead and start dividing. Now, when I divide a decimal number by a whole number, I tried to consider the decimal at the end. So I treat it like it's a whole number. So we're going to treat it like it's 432. Okay, so the first number is 4 hundredths, we'll say, without the decimal. And I'm asking myself, can I divide that into 6 different groups? And just by itself, I wouldn't be breaking it apart yet, just keeping them as 100 each, 4 of them. So I cannot do that. I need to break it apart more into tens. So I'm going to combine the 400 with the 3 tens and make 43 tens, right? So can I divide that into 6 groups? What do you think? Yes, you can. So how many can you put into each group? You want the largest amount you could put in each group. And so if you know your multiplication facts, you should be able to think about what that is. And if you don't, grab a multiplication table and go ahead and look at that. That's fine. The focus here is division, but multiplication and place value are important. So yeah, it's going to be 7 because if I put 7 in each group, right, we divided first. Now we're multiplying. We're going to find that if I put 7 in each group, that's going to be 42 that I've divided up. All right, 42 tens, we'll say. And now I'm going to subtract. But that's also 70 then, right? So it's 420 here. And now I can subtract. So 7 tens is 70. And 70 times 6 is 420. Now I subtract. And let me put that over here. And that it leaves me with 12. Okay. So now I divide 12 by 6, okay? Can I, first of all, let's check. Can I keep dividing? Can I divide 12 by 6? Can I put 12 into 6 different groups? Yeah, sure I can. I can keep dividing those up equally. So how many would go in each group? Yeah, if you said 2, that's correct. 2 in each group because 2 times 6, okay, we're going back up to divide. And then now multiplying, 2 times 6 is 12. All right, now we subtract, and we're left with 0. So we divided it up. You divided your first decimal number, if this is your first time, by a whole number. All right, now, but we're not done. We have to add up these partial quotients, and that gives me 72. But remember, you had a decimal number you were dividing. So let's think about this. This number, 43 and 2 tenths, is how many times smaller than 432? Think place value here. This is where place value is important. Yeah, you should be saying it is 10 times smaller than 432 because it's shifted to the right one place value. It is one place value smaller, which in every place value to the right is 10 times smaller than the one to the left. So it would make this number up here, my answer, 10 times smaller. Okay, I'm dividing up a number that's not 432, it's 10 times smaller. So my answer would be, in this case, 10 times smaller. It's a smaller amount. So what is one place value smaller? It's 7 and 2 tenths. It's one place value this way. The digits shift this way, one place value. All right, and that moves this decimal over. So hopefully that helps you to think more about how the place value is affected at the end. That's important. We need to consider that at the end so that and shift the digits the right way. So in this case, whenever you're dividing by a whole number, a decimal number by a whole number, the answer is going to get a little bit smaller depending on how much smaller that decimal number really is. Okay? So it's 7 and 2/10. Also, I want you to look at our process for dividing. When we divided a decimal number here, okay, look at this. Did our process change versus when it was a whole number? Did anything change? No, nothing has changed. So the only thing that changed is I shifted the number to be to the answer to be smaller by one place value. You'll also see there's one digit in a decimal place value. That gives me another clue. That tells me I can shift it one place as well. All right. All right. Now we're going to move on to the next number. Okay, this one is 297 and 5/10 divided by 34. Again, divided by a whole number. So I'm going to write the steps over here. First we divide, then we're going to multiply, then we're going to subtract and check to see if we can keep dividing. All right. And if we can, we're going to go back up to the top and divide again. All right. So 34. Remember when we were dividing whole number by a whole number, we were kind of using a starting number that we rounded to from 34 or our divisor that would be easier to divide in our head. So we're choosing this power of 10, 30. So some people say, how many times does 30 go into 290 or 2,975, thinking this as a whole number? Well, it's not really going into. Remember, we're dividing it up. We're dividing 2,975 up into equal groups. Again, we're going to consider the decimal last. So right now, just dividing it up as a whole number. Okay, so let's look at it digit by digit, place by place. Does 2,000s, do they divide into 30 or 34 groups? No, not as 1,000 without breaking it apart. No, we only have 2 of them. So we need to make 2,900s and see if that works. This is the next place value if it's a whole number. 2,900s. No, that won't divide either. It's smaller than the divisor. That should be your big tip. Okay, so let's try the next one. 297 tens. Yes, that would divide. All right, so now I'm going to think, what times 30 is close to around 297? Because they're tens, right? So what times 30? So again, knowing your math facts. What times 3? Then shift it one place because it's 10 times bigger. Let's see. Well, I know 5 times 3 or 30 would be 15 or 150. So that's too small. So I'm going to go up. Let's see. And you can skip count down below if you want. So you could do 3, 6, and keep counting up until you get something close to this number. And again, shifting it one place more, bigger, because it's 30. All right. So I know that 5 was too small, so I'm going to try a larger multiple. How about 7? 7 times 3 is 21. So 7 times 30 is 210. That's getting closer. I think I can keep going larger. So I'm going to try 9. 9 times 3 is what? That is 27. So 9 times 30 is 270. Okay. How about 10? Well, 10 would be too many, right? For one, I only have one place here to put the digit. I'm dividing this number up by. So it should be 9. 10 would be 300 anyways, and that would be too much. So we're going to put a 9 here, right? We're going to put a 9 up here. So 9 tens in each group, right? That would be 90. And then 90 times 30 is actually 2,700. But what's 90 times 34? So this is where you have to do a little extra work, okay? So when you have a 2-digit divisor, it helps to do a little extra multiplication on the side to make sure. So I use this expanded notation method, okay? And it gives me some partial products. So it's easier to multiply. So 90 times 4 is 360, okay? All right, 9 might be too big still. We'll see. And then 90 times 30 is 2,700. Okay. Now, looking at that, I can already tell that's going to give me 3,000, something more than 3,000. I can't put 3,000 here because I cannot subtract next, and I cannot subtract 3,000 from 2,975. So this was a bit too big. So I'm going to keep my box here because I'm going to need it again probably. All right. And kind of erase this work for me. You can keep it on your paper. And sometimes that happens. Sometimes we pick a partial quotient that's too large. So what's the next number down? You're going to pick, yeah, that's right, 8. All right, this 30 just gives us a starting point, and we may have to do more work. So 80 now times 34. So I'm going to change this to an 80. All right, so 80 times 30, and you can set up another box for your multiplication and leave the other one because you probably have more room than I do. And now 80 times 30 is what I'm multiplying, and you get 2,400, okay? And then 80 times 4, what's that? Yeah, I want to let you do some of the work. So you can always pause the video too in between to kind of give yourself more of a challenge. 320 is our answer there. So now we add these together. And you could probably do that in your head. It's what? Yeah, 2,720. Okay. Now I'm going to subtract. These problems take a while, don't they? Okay, so now we subtract and we get what? 5, 5, and 2. 255 left to divide. So I check now. Can I keep dividing? Yes. So consider it to be like a whole number still. Don't worry about the decimal yet. And let's see, 255 ones. What times 30, again, is close to 255? Let's see. Well, 8 times 30 is 240, okay? Right? 8 times 3 is 24. We know that. But we also know, if you look up above, that 8 was 880 times 34 gives us 2,720. And if I just do 8, that's going to be 272. And that's going to be too large. So use this information you've already, use your calculations that you've already made to help you. So now we're going to try 7 because 8 would be too large. It would be 272 because it's 8 times 34. It's not 10 times bigger like this. So we're going to do, whoops, I just got my mind stuck on 8. So we're going to do 7 in each group. If I do 7 ones in each group, I should be able to divide this number up, and we're going to do 7 times 34. So let me find some space down here. 7 times 34, okay? And let's see, 7 times 34. So 7 times 30 is 210, and then 7 times 4 is 28. Okay, so yeah, that gives me an answer of 238. 238. So let's put that in. If I add those in my head, 238. Yes, so that was a good choice. Now I can subtract and see what I'm left with. And I'm left with, I'm going to have to ungroup this and subtract. And this becomes 10 times bigger. It's 15. Now this is 7. And this is 1. So it becomes 17. Can I divide 17 up? No, I cannot. So I'm going to have to add a 0. Add a 0. Can we do that? Let's think about that. Yeah, this ends up being a great problem for us to practice because we're going to do something that you're not used to. We're going to add on a 0. If I do that, I want you to think again, place value. Does it change the value of any of these other digits? No, it just makes what we're dividing up, we just divide it up into a smaller place value, okay? So I'm going to add zeros going down for all these digits and numbers, and I'm going to add a line or a column of zeros for my answers up above. And we'll see how that affects the answer later. So we're adding on a 0, annexing a 0, and now I'm going to divide 170 because now I can divide that. 170, we'll say these are 1s again, and because we made up above the 7 10s, I guess, and the 800 or 8,800. So now we're going to divide up 170. What times 30 is close to 170? Remember what I said earlier at the beginning of this problem? Yes. How about 5? So put 5 up here, our answer, and our work is getting so long. Let's try 5. So 5 times 30 is 150. So what would 5 times 34 be? Again, I will do some work down below. 5, running out of space. This program that is web-based is great. This online whiteboard. It's made by the mathlearningcenter.org. It's completely free, but it only gives us limited space. So 5 times 30 plus 4. Okay. So now 5 times 4 is 20. Okay. And then again, 5 times 30 is 150. So you will see now, hey, that's what we needed. 170 is what we needed. So that was a great partial quotient answer because it leaves us with 0. All right, so if you're dividing a decimal by a 2-digit number for the first time, this is kind of how it all works. Now, we're not quite done. We're going to add these up like we would if they were whole numbers, and we get 875. But now we're going to consider the decimal. All right. Remember, we ended up dividing up a large number, and we considered it to be like a whole number. But how many times smaller is this number in reality? The key is to look at the place values. Each place value is how many times, when I go to the right, how many times smaller? Yeah, 10 times. So this is 10 times for the 5 and 10 times for the 0. So that's 100 times smaller. So that means this digit shifts this way. It shifts this way 2 places, okay? And it ends up being here. The decimal moves over 2 places here. So if it was a whole number and it started here, that's where it ends. 8 7/75 is our answer. Instead of 875, it's 100 times smaller. All right. So this takes a while to figure out, but as you do it more and more, you will get the hang of it, okay? Okay, so our next problem is right here. I'm going to give you some time now to try this one on your own. You can go back in the video or your notes to try to look at how I did those problems and see if that helps you. I will start you off with a starting number to help you divide. I would estimate or round this to 10 to kind of estimate my partial quotients to begin with, okay? So something times 10, that'll be easier to do in my head than something times 14, because we're putting whatever we put up here in the partial quotient section, we are multiplying times 14 because it's equal groups. 14 equal groups in this case, but I can do 10 in my head much easier. All right, so go ahead and pause the video and give it a try, and then I'll reveal the answer as you push play later, okay? All right, I'm going to go ahead and reveal the problem or the answer in my work. See if it matches yours. All right, boom, there it is. So if you look at this problem, it took a lot of work again, as you know, and it was a little tricky because we did have to add a 0 on the end of the number and to continue to divide up as a decimal. So then at the end, we ended up with 1,225. The number shifts 100 times smaller, so 2 place values, because there's 2 decimal place values that end up in the dividend, the number being divided, okay? So and I did a little work on the side. I didn't really need to do it for 200 times 14 because I know 14 doubled is 28, and then it shifts 2 places larger because it's 200 in this case, or 1,000 up above here, and shifted that the way it needed to be. And then we found out that we could just do 20 as again. We could use that multiple again for the next amount left. All right. And we ended up with 7. So we had to add that 0 to continue to divide up the place value. All right. Or the amount. So 12 and 25 hundredths is our answer. Okay. If you need to work through this again, go ahead and give it a try. See if it makes sense a second time. It's never, I know it's a bit of a pain, but it's never a bad idea to go through and try these a second time, starting from scratch. You'll probably be better at it, most likely, and it will definitely make you feel more confident with the actual steps for dividing. So that's it for today, and I hope this video worked for you. Until next time, ciao.